Hello everyone, welcome back. So in this video we are going to understand the balance binary tree Leetcode problem number 1110, and we are going to understand in Java solution with O of n time complexity. The very first, have you ever looked at the binary tree and wondered, is this a balance binary tree or is this tree is balanced, right? And the more importantly is that how do I check in O of n time as a complexity without over complicating it? Okay, so today we are breaking down this problem and we'll try to understand the very simple steps. As we can see, these binary trees we have given, is this balance or not, that we will try to understand, and we'll fix this once for all to understand how to implement this type of problem. And this is the constraint we have also given. Okay, very first we should understand, or this problem that we have given is binary tree is balanced if every node that we have given here, right, the height difference between its left and right subtree is not more than 1. Okay, what is the left? Let's for this part, let's suppose we know that this is also a tree that is called subtree of this tree, the entire tree, right? So if we talk about the every node, either this node, this node, this node, this node, right? So what the statement saying that for every node, let's call about this node, the height difference between the left and right, what is left? We have 0. What we have right is 0, means both is 0. So if we'll take the height difference between the left and the right, let's suppose it should be not more than it should not be greater than it should be less than equal to 1, we can say that. Okay, so the difference, so this is called difference, height difference, you can say this height difference. Okay, so it should not be greater than should not be greater than 1, you can say that, means it should be less than equal to 1. Okay, that is not the root only, but we have to go for all this one. Okay, make sure that, so let's suppose if you're talking about this one, what is the difference is there? So if we'll calculate it, it should not be greater than 1, it should be less than equal to 1. So at every node, if one node valid this problem, right, the tree is not balanced. Okay, anywhere if this rule is getting violated, right, means this tree is not validated. So the real question becomes, how do we efficiently calculate the height, and will verify, how we will verify the balance at the same time at each node, right? This is the question we have in the balance binary tree, right? Very first, how do we find or calculate the heights, and how do we verify the balance at same time? Okay, I hope you're understanding that, guys. If you have any doubt, you can ask me in the comment section. Let me explain again here. Let's call, we have 3, 9, 20, 15 and 7. These are the given nodes we have given, and let's try to compute height from bottom up, right? You know the bottom up, right? This is called bottom up. And so let's start with very first is 9. Okay, what is the height of 9? So if I'll say, okay, node 9 we are talking about. Okay, so what is the height of the here? So we'll say height is 1. Initially we'll take height is 1. Then we'll talk about node 15, right? Node 15, what is the height of node 15? It's also height is equal to 1. Let's talk about node 7. Okay, node 7 height is 1. So these three have height as a 1. Now let's talk about node 20. Let's go node 20. So once these basic childrens we have calculated, then we can check that the node we have is 20, and for the node 20 we have two things. Very first is left and the right, right? So left height we have seen that we got 1, and the right height we have gone is 1, right? 1, 1. Now we need the difference. Let's call difference is in starting 1 minus 1 is nothing but 0, means this is a balance, right? This is a balance node. Node 20 is balance, correct guys? Let me write full. Node 20 is balance, and so we'll say this is a good node and we are getting balance. And we say that. Come back to again and let's check node 3 this time. Okay, now if you find this part completely, right, L for the root node 3, the left height is equal to, we have seen that 1, we'll say 1. Right height is, we have to find, right height, so we know this 1 and this is 1, it become 2. So the difference is absolute value we have to take, right? Right minus left, we can say that is nothing but 2 minus 1 is 1, which is also a balance tree. Okay, so if the root is balance and all its children is balance, it means what? This is having 1, left 1, it will find this node is 1, and similarly for this one is 1. Okay, and even for the root 1 is also balanced, and that is why it become balanced, means we will return true, right? So what we have to understand, for the binary tree is balanced if every node, the height difference between its left, we are talking about either in anywhere in the subtree, so left and the right subtree is not more than 1. The height difference between the left and the right subtree is not more than 1, and that's only not for the single node, but let's suppose for the root, but for all its children. At the same time, we have to find two things. Very first, you have to calculate, and if any of this is violating the rule, but like difference is not greater than not less than equal to 1, which means it's not balanced. So in this case, we can say it is getting balance. This is what we have to try, we should understand before jumping into the problem. So let me explain a very simple which is not balanced. Let's suppose in this case, so look at a tree. If root is 1, it has a children 2 and left children, and again we have a right children, left children is 3. So if this is a tree, right, so the root, if we'll talk about the root, no, for the root node, what is, we have 1, and left height is nothing but 3, because if you keep going, left height is 3. Now we will find the right height, which is nothing, is 0. It means if you will find the difference, so absolute value 3 minus 0 minus 3 or 3 minus 0, whatever will come, absolute will take, it will come 3, right? So it is not balanced, guys. Okay, not balanced. That's the skew tree. We can, if you remember that, it is called a skew tree. So it's a skew tree and it's not balanced, and it is not balanced because the difference is not less than equal to 1. If it exceed 1, so this is not balanced, and so we will return, in this case, not true, but we will return false. Now the question comes is, how should we traverse, right? How should we traverse? How we are going to traverse the things, and we have to understand, right? This is what we should understand before implementing the problem, right? You can take a note here and you will say how should we traverse, right? So very first, think carefully and check balance at our node, and you must know the left subtree height. Or let's suppose for this one, we know what is the left subtree height and the right subtree height. If you talk about this one, you will know that the height of the left subtree and right subtree and left subtree, right? So what we have traversed, what traversal do we need is post order, guys. Okay, if you do the post order, I know that you are aware of that very first we have to go to the left, then we should go to the right, and then we have to traverse to the root, correct? So if in this case, if I'm talking about, we'll complete the left one first, then the right, and then root, left, right, and root we have to go. So this is called the post order traversal, and we should traverse in the post order. So we must check left subtree height, right subtree, right? So in case if you're not understanding post order, pause this here and try to understand post order, right? It's very good to understand. Now it's time to understand further. So we know that we have to move to left to right to root node, right? Because you need child height before the parent. So if we need child height before reaching to the parent, it means we have to go left, then right, and then root, right? So traversal for this type of thing is become how? Very first we'll traverse to node 9, then we should go to the right subtree. So right subtree is a tree, is a kind of, this is called tree, right? Subtree is a tree. So in this we will go first the left part, then the right part, then root. So we'll say we'll go 15, then we go to 7, then we go to 20. Once 20 is done, means this subtree is done, right? Now we'll go to the root. So this is called, guys, post order traversal, where you have first traversed to the left, right, then from here to here, this is your right subtree, this is your left subtree, this is your right subtree, and this is your root. Okay, so we compute heights while coming back up, and this is called, guys, we know that bottom up approach. Okay, so make sure that you are understanding everything here. So most beginner try to do what as a common mistake. Most beginner will write the right height function, then for every node he will compute the height left, height right, and recursively they will check the balance, right? So this will work, but it recalculates the heights again and again, which makes it worst case for the time complexity, and it will go for O of n square, guys, right? So do not try this one, because if we can solve the problem in O of n, no need to go for the O n square, right? And that will hurt you in the interview if you talk like this, right? So you don't want to repeat this work again and try to solve by one step in a post order manner like we have explained here, right? Better, here is a smarter trigger you can apply. Let's suppose instead of returning the height only, we return height if balance, otherwise return -1 if not balanced. Let's suppose for this part of tree where 20, 15, and 7 is there, let's suppose if this is balance, we will return the height, otherwise we will return -1 as a not balanced, right? Why? Because the moment a subtree is unbalanced, right, we don't care about the height anymore, because if subtree is unbalanced, its tree is also unbalanced, right? So just propagate -1 upward if it is not balanced, right? So at every node, get the height. If -1 returns, return -1. If the, let's suppose going for the left height, right height, right, wherever you will find the -1, it means you are returning -1, which is not balanced. If you're returning some height, means it is balanced, right? So it become a easy trick to do that. Let's suppose if you are able to return from the left and right side both, that you want to return some height side, obviously you have to find the difference, and you will check if difference is left minus right height is greater than 1, return -1. Otherwise just return the max between the left and right. you do +1, so you will get the height, right? And for each node, the visibility only once it will come, and time complexity term of 1, which will become the very good time complexity, right? What I'm trying to say is that, let's suppose you are going for the left, right? So get the left height. If let's suppose it returns -1 from left side, means you will return -1, because this is not balanced. So the left height you will get like this. Similarly for the right height, you will try that, you will check if you are returning -1. If the height is the same, so you will return -1, otherwise you will get some height. If not, right, left, right, let's suppose now you going for the root, you are finding what, left height minus right height. If it is greater than 1, you will return something here, right guys? You will return, let's suppose if it is greater than 1, return -1, right? Otherwise what you need to do is return the max between left and right, and do +1. So this is your difference, right? So now at each node you have visited only once, and it will take you of 1 time as a time complexity, guys, and it is very clean, and for the interview perspective you can use it, right? I'll also explain this way how to implement it. Okay, so keep watching. The very first, this is the way we can check the height, right guys? Okay, for the balance, right? Let's suppose if you're trying root is equal to null, you will return true, otherwise you will get the height, left and right height, and you will check the absolute value, the difference, if it is less than equal to 1, and for the left minus height, left height and right height, and as well as you will check the left is balance and the right subtree is both subtree is balance. It means you will find that this is a balanced one, right? For checking the height itself is a function where you will pass a node, you will check if node is null, you will return 0, otherwise you find the left and the right. So internally it calls, recursively it calls the against height function, and it calculates. How? You just check math dot max you are doing, and left height, right height you are calculating, you are just adding +1. So this way basically we increase the height, right? For jumping to, if you have the left height and right height, you have to find the max height, which is the max height, and just you will add +1 to get one more layer, one more level of the height, right? So like that you will find the height, guys, right? So for any root node, very first you have to check if root itself is null, return true, otherwise for the root node go for the left subtree, right subtree, and find its left height and right height. And you know how to implement this. For the height, you will think that this is just a node. If node itself is null, return 0, otherwise calculate its other subtree height, left and right height, and you will return the height of the node, like you will do +1, which is the max of the left hand height. And if it is max, left height minus right height, you will check less than equal to 1, and you will do if balance root dot left and root dot right means left subtree, right subtree is balance, means the root is also giving the condition should be less than equal to, means the tree is balance. I hope you are understanding, guys. Now if you want to optimize, how you are going to optimize? The very simple way is, as we have discussed, let's create the height, right? So before creating returning the height, you directly let's return the height, guys. HAGST height, height, height. So to get the height, you have to pass the root node, guys, right? If root node returns what, -1, if it is -1, you will return, it should, it's, if it is -1, then you will return not balanced, right? So here itself you will check this thing, is it not equal to -1, means it is balanced, right? This condition will say true or false, and based on that you will return the tree is balanced or not balanced, correct? Now very simple thing is that we will define private int height, and as a root node we can pass any node. Let's call the tree node, and this is nothing but a node. Okay, now we'll check if the node itself is null, right? If it is null, we know that the height is nothing but a balance is 0, right? Then we'll check int what is the left height, and we'll say we'll use the same thing as we have passed here, right? How? You just need to pass here node dot left, you will pass, correct? Similarly we'll do for the right. Here we'll pass right, and this will become right. So you find out the left and right subtree. If the left and right having some node, you will return. Otherwise we should make the condition is that if the left node, left subtree gives you -1, so you don't need to check further, you return -1 here as a height. Otherwise you will keep continuing checking the right subtree. You will check if right is equal to -1, so no need to check further, and return -1, it is not balanced. If both is good, not going to the condition as equal to -1, it means we are reaching to the root node of the subtree or node. We'll say okay, math dot absolute value, if you'll take left height minus right height, if this difference itself is greater than 1, it means it's not good, it's not balanced, return -1. In otherwise cases, right, we will return the difference. We'll say just math dot max, and what is the difference, or what is the max height, +1 we will do, and we'll return it, right guys? As simple as we have discussed, right? This is the optimized way, and we can do like this. What we have done here, so instead of returning height only, we will we are returning actually the height. Let's call here itself we are returning, so we will return height. As we can see here, we are doing the max height +1. And why? Because the moment the subtree is unbalanced, right, we don't care about the height anymore, right? Because if you see, when we are going for, let's suppose for this root node, we are passing the root node, right? The very first node from is root node, and after that we have two children, left subtree, right subtree. So when we are coming to here, if root itself is not null, it means we will go further, right? We will find the left subtree. So when we are going for finding the left subtree, right, we'll check if the left subtree is returning -1, right? If the value is -1, means we don't need to care about the height anymore further, just return -1, right? Because it is unbalanced. The rest of the code is not need to go further to check, right? So we just propagate -1 upward, and it will return. If it is -1, it will say okay, this is not true and return false here, right? It means the given tree is not balanced itself. Similarly, for the right thing, we'll do if left and right is fine, not equal to -1, then we'll check the difference. The difference should not come greater than 1, otherwise return -1. Otherwise you have to find the height for each upward is +1, or downward you can say +1 will take, and like that we will return the max left right, which we're only having the max value +1. And now we'll visited each node only once, and so the time complexity is of 1. Sorry, time complexity of n, right? It means you have noticed something powerful here is that we never calculate height twice, right? We combine height calculation and balance check, right? We have checked the balance check, and we move into one DFS traversal, you can say, and that is the key of this problem. Okay. Sorry. So if you want for the brute force approach, right, if you're thinking that I can do with the brute force approach as a top down, right, it is easy to think, guys, but it will take O of n square that we have already talked about. And if you go for the optimal way, you can use the bottom up, where you can do O of n times, that will be the clean that we have shown the code, and interviewer favorite is also. You can also use the iterative way with the stack. Okay. And if you're doing with the iterative way with the stack, right, try to avoid recursive stack, otherwise it become a very complex to implement, which is rarely required in the interview. So if you are comparing seriously, master the bottom up approach that we have discussed and try to implement in that way. If you are in the interview, I'll give some tips to understand. If an interviewer asks this bottom up problem, this problem you can say, so don't just start coding. Say this, that I will compute height bottom up using the Postorder traversal and propagates -1 if imbalance is found, and that's the sentence along with a signal that you have the depth understanding, and interview will go well, right? Because see, balanced tree is not about the trees, it's about avoiding repetitive work. You don't need to repeat again finding the heights, right? You don't need to repeat the again. Once you understand bottom up recursion, many tree problems becomes easier. And if this help you, please like this video and comment balanced, and subscribe for more FAANG level DSA breakdown, guys. If you see anything missing, please write in the comment section, so I will improve in the next video. And that's all I have. Please subscribe and support ExpertFunda. If you are struggling with DSA classes, Java classes, you can join our online classes. And basically first you have to ping through the WhatsApp, and then we'll go from there. Thank you. Bye bye. I'll see you in the next one.